Hello everyone, welcome back to Mad About Design. In this tutorial, I am going to show you how to design this Oldham coupling using Autodesk Fusion 360. Those who don't know, Oldham's coupling is basically used to transfer the rotational motion between two shafts when they are not linear. Here you can see the axes of these two shafts are not linear. Hence, a disc has been used to transmit the rotational motion from this shaft to this shaft. This coupling has mainly 5 components. First, this flange, the flange 2, the center disc, and these two shafts. And we need a base, or you can say the frame, to hold these two shafts. Here are the dimensions of the components and the tools and commands I am going to use in this tutorial. If you are new to this channel, do subscribe to us and turn on the bell notification so that you won't miss any of our new videos. Now, without wasting time, let's get into it. First, create a new design by going to File, select New Design. The unit I am going to use in this tutorial is millimeter. You can change it by clicking here, unit type millimeter, and OK. For this tutorial, I am not going to follow the conventional process in which we create the component first and then we sketch and create new bodies. As we follow the tutorial, you can see that I will create the components after sketching while creating the new body. Don't worry, we will go through it together. So, first create a new sketch on the top plane. Go to 2-point rectangle. Draw the first rectangle from the origin and give it a dimension of 12 by 27 millimeter, followed by another rectangle from this point having dimensions of 12 by 17 millimeter. Press enter. Arrange these dimensions. Go to 2-point rectangle again. Select the first point on the geometric midpoint of this edge and give it a dimension of 60 by 5 millimeter. Now go to straight line command and draw a straight line from this edge up to this edge. Go to sketch dimension, select this line and this line and provide a vertical distance of 5 millimeter in between them. Go to trim command, trim out these edges, press escape, go to 2-point rectangle again and change it to center rectangle. Select the center of the rectangle as the geometric midpoint of this previous rectangle. Here you can see, and give it a dimension of 22 by 3 mm. Press enter. Go to sketch dimension command. You can directly press D. Select this edge and the center of the rectangle and make sure it is 6 mm. Arrange the dimensions properly so that you can have a clear look of the dimensions. I will hide the constraints and construction geometries. Let's hide the dimensions also. Here is the clear view of our sketch. Finish sketch. Go to Revolve command. Select these two profiles, and for the axis, select this axis. Extend type, full, operation, new component. Click OK. So here we have got our first component. Let's rename it as flange 1. Turn on the visibility of previous sketch by going here. Go to Revolve again. Select this rectangular profile. We can hide this flange component. For the axis, select this axis, operation, new component, extend type, full, click OK. Here we have got our second component. Rename this as shaft 1. Let's activate the shaft 1. Go to extrude command. Turn off the visibility of bodies. Select this rectangular profile. Drag it upward and turn on the visibility of bodies. Change the operation to new body and extrude it up to 6.5 mm. Change the operation to join. Click OK. Let's chamfer these edges. So under modify, go to chamfer, select these sharp edges and chamfer them up to a distance of 0.5 mm. You can make it 1 mm. It looks good, so click OK. And chamfer these edges too. up to 0.5 millimeter. Press enter. Here is our shaft 1 ready. Go back to main assembly. Turn on visibility of flange 1 and hide the sketch. Here you can see our flange and shaft is overlapping. So we need to cut the body part from the flange. So under modify, click on combine, target body, the flange, and for the tool bodies, select the shaft. Operation, cut, and make sure you turn on this keep tools option. So after cutting the bodies from the flange, our shaft will remain here. Click OK. If I move this, here you can see the slot has been created on the flange. Revert back to original position. Keeping the main assembly active, let's create another sketch on this face. So create new sketch. Before proceeding, let's project this circle on the current sketch. To do so, go to project, or you can directly press P to go to project. Selection filter, specified entities. Select this circle, turn on the projection link and click OK. Here you can see the flange, the outer circle of the flange has been projected on the current sketch. Go to 2-point rectangle, change it to center point rectangle. Select the center of the rectangle as the origin, or you can say the center of the circle, and give it a dimension of 12 mm by 60 mm. You can take any length which is bigger than the diameter of the circle. You can also take 65 if you want. Arrange these dimensions properly and finish sketch. Go to extrude command, select this profile, drag it inward up to -6 mm. Hide shaft 1, operation, cut and click OK. Turn on the visibility of shaft. Turn on sketch 2. Go to extrude again. Now I'm going to create the center disc. So select this profile and this circle to drag it inward. Change the operation to new component and make sure you drag this profile up to this surface, that is -6 mm. Operation, new component and click OK. Here we have got our third component. We need to design further on it, but for this moment let's rename this as center disc. Active this component, go to extrude again, select this circular profile and extrude it up to 3 mm. Operation join, so that this disc will be joined with this rectangular part. Click OK. Now I am going to mirror this portion on the other side. So under create, go to mirror, object bodies, and for the bodies select this part, and for the mirror plane select this surface of the body. Operation new body, because I am going to rotate this portion. Click OK. Press M to go to move command, move object, select the body, select these bodies from the center and rotate it at an angle of 90 degrees. It looks good, so click OK. Hide sketch 2. Let's join them together. So under modify, go to combine, select these two bodies, operation join and uncheck keep tools. Click OK. Here is our center disc ready. Go back to main assembly. Now I am going to copy and paste the flange and the shaft on the other side. So let's select shaft and flange, right click and copy. Right click on main assembly and paste new. Here we have got our copy of flange and shaft. Move them like this and rotate it up to 180 degrees. And little bit closer. Let's keep it here. Capture position and click OK. Let's rename this one as flange 2 and this one is shaft 2. Here you can see the flange one is grounded. Here you can see the icon. That means the flange one won't move from its original position, whereas you can easily move other components like this, but it won't move because it is grounded. Revert back to original position, and also you can see that there is no joints in between the components. So let's provide some joints, but before that revert back to original position. Under assembly, go to as-built joint, select the shaft and the flange, motion type rigid, preview motion, click OK. So they are rigidly joined together. Go to as-built joint again, This time select the center disc and the flange one. Change the motion type to slider and for the snap option, hide this center disc and select this line. So the center disc will slide along with this line. It looks good, so click OK. It's time for the flange 2. This time again go to as-built joint and select the flange 2 and shaft 2 and provide a rigid joint in between them. Go to joint this time instead of as-built joint, because I'm going to provide the joint relation between the center disc and the flange 2. As you can see that they are not aligned properly and they are not aligned together. So I need to apply the joint instead of as-built joint. For the component one, select, let's hide the shaft 2. Select our flange 2 and for component 2 select center disc. Rotate this at an angle of 90 degree. You can see it from here, 90 degree. And for the motion, change it to slider. It is sliding along the z-axis, change it to y. It looks good, so click OK. Turn on visibility of shaft. As you can see, these two shafts are aligned properly, means they are linear. In order to make the Oldham's coupling work, we need to misalign these two shafts. To do so, press M to go to move command. Change the objects to components. Select this shaft, flange and the center disc and move it in downward direction up to minus 7.5 mm. Press enter. Now it looks okay. Before going further, I would like to say that creating this type of tutorials takes a lot of time to do the research, designing, then scripting all these steps and recording and then editing the full tutorial. For you, it does not cost anything to subscribe to this channel. It motivates me to keep creating new contents like this. I don't have any team, so it matters a lot. Now moving back to the tutorial. Now we need to create a base or frame in order to hold these two shafts. To do so, create a new sketch on the front plane. It is saying the components have moved from their original position, whether I want to capture the position or revert back to original position. So capture the position. Press P to project the components on the current sketch, selection filter specified entities and click OK. Go to straight line command, directly press L, draw a shape like this. Click OK. Press D to go to sketch dimension command. Select this point and provide a vertical distance of 32 mm in between them and a horizontal distance of 12 mm. Repeat the same steps on the other side. Repeat the same step on the other side. Provide horizontal distance of 12 mm. Select this point and make them horizontal or vertical, so they will be horizontally aligned to each other. Press D to go to sketch dimensions again. Select this point and this line. Provide a vertical distance of 54 mm. Under Modify, go to Fillet. Select this corner and provide a fillet radius of 15 mm. Click on this corner also, so the same radius will be applied here. Press Enter. Under Modify, go to Offset command. Select this profile, drag it inward up to 7 mm. Press Enter. Go to Straight Line again and close the profile as follows. Finish sketch. Go to Extrude. Select this profile. Change the direction to symmetric and extrude it up to 20 mm. Change the operation to new component. So the total length of the component will be 40 mm. Click OK. Under Modify, go to Chamfer. Select these edges and provide a distance of 10 mm. Press Enter. Now go to Combine command. For the target body, select the base, and for the tool bodies, select the shaft 1 and shaft 2. Change the operation to cut. Check this Keep Tools option and click OK. Here is our frame ready. Let's rename this to base. Unground the flange one and ground our base. Let's provide revolve joints in between the shafts and the base. To do so, go to As-Built Joint. For component 1, select the shaft, and for component 2, the frame. Motion type revolute, and for the snap option, select the surface. It looks good, so click OK. Repeat the same thing for the other shaft. snap option this surface, click OK. Now go to joints, right click on revolute and animate joint relations. Here you can see our Oldham's coupling is working successfully. You can hide the base so that we can have a clear view of the Oldham's coupling. Let's color them little bit. Press A to go to appearance. I'm going to apply this paint metallic red color for the disc, black color for the flanges and white color for the shafts and the base. Hide the joints and animate the model. I hope you guys have learned something new in this tutorial. See you in the next one. If you like this video, hit the like button and don't forget to subscribe to our channel. See you in the next tutorial. Till then, keep designing and design whatever you love. Bye bye.